Hi everyone, welcome to my channel Design with Rusbe. Continuing with CSWA Practice Problems, today we'll work on question 5.8. Let's take a look at this question. So in this question, unit of measurement is millimeter gram second. Like always, we need to ensure that we are using the same unit of measurement in SolidWorks setting. Now, looking at this geometry, this is geometry with weird angles. The whole idea of this question is to help you understand how to make a plane. So in this question, you can see different view. We have the 3D model, we have the top view, and we have the front view. My preference is to focus on the front view and a base of the geometry. You can see that we have this sort of shape here. I'm going to focus on that one, and first I'm going to make that part of the geometry. Then after that, it's time to focus on this top feature. In order to make that top feature, I'm going to take advantage of adding lines and then making a plane. And then eventually I'm going to make this sketch on the new plane and extrude that feature. So with this introduction, let's jump into SolidWorks and start modeling this part. In SolidWorks, first we need to ensure we're using a correct unit of measurement, and you can see that we have millimeter gram second, which is a correct unit of measurement, so we are good to go. Click on the sketch, and choose front plane. As I mentioned, first we want to focus on the base of the geometry, so let's click on line command, and then this is going to be an easy sketch. So something like this. Okay, so now looking at the front view, we know that the overall thickness is 13 millimeters. So let's add 13 millimeter here, and same here. This should be 13 millimeter. Also, the angle between this line and this line should be 150 degrees. The length of the top line is 77 millimeter. But you can see that the geometry is not fully defined because we need the length of this top line. Let's go back to the question. I want to show you something. In the question, you can see that for the top view, we have 50 millimeter here, and we have a circle here. The diameter of the circle is 60 millimeter. That means that the radius of the circle is 60 millimeter divided by 2, which is 30 millimeter. So if I add 30 millimeter to 50 millimeter, that means that the overall length of the top line should be 80 millimeter. So let's add that to our geometry. Based on what we discussed, this length should be 80 millimeter. Okay, so now I have this geometry. Everything is ready. I can extrude this. So let's click on feature, click on extrude bus, and then here I'm going to change it to midplane. According to the top view, the overall width of the geometry, which is equal to the diameter of the circle, is 60 millimeters. So I'm going to put 60 millimeter here. Click on OK, and that's it. Okay, so now I have the base of the geometry. All I need to do is to add a fillet in this corner. In order to add fillet, you have two options. Go to feature, click on fillet command. One option is to click on simple fillet and choose 30 millimeter radius and click on both corners, this corner and this corner. The other option, as I showed you in the previous video, is to click on full round fillet, which is an easier option for this case. So basically here you select three different surfaces: surface 1, surface 2, surface 3, and now SolidWorks automatically converts these surfaces into a round fillet. Click on OK, and that's it. Next step, adding a hole to the center of this geometry. So click on the sketch, and in order to add a hole, I need to select this surface. So select this surface, click on circle command, and then here I'm going to make a circle. Click on a smart dimension and add dimension to it. According to top view, the diameter of this hole should be 25 millimeter. Click on OK. Click on feature, click on extrude cut, and cut this. Okay, awesome. So now we have this part of the geometry made. Next step is to focus on the feature with weird angle. Let's go back to the question and have a look at that feature. In the question, you can see that the feature starts on a plane with 60-degree angle. So we need a plane with 60-degree angle with respect to horizontal line, as shown here. But at the same time, that plane needs to have another angle as well. If you look at this view, you can see that that plane has 75-degree angle with the top plane. So we need to take into account both of these angles. What I'm going to do, I'm going to focus on this part first. I make a center line or a line as a reference. I make a plane on that line, and then I'm going to add 75-degree angle to that plane. So let's go back to SolidWorks and try this method. So here, first we need a reference line to make a plane. So click on the sketch, and choose this surface. Now click on line command, and then here I'm going to make a line. Of course, this is a construction line, so click on it and change it to construction line. According to the top view, the angle between this line and this line, horizontal line, should be 60 degrees. Also, the distance between the starting point of the line and left edge should be 25 millimeters. And that's enough to have a line. Okay, so exit this sketch. Okay, so now we have the reference geometry here. We are ready to make a plane. Let's click on feature, click on reference geometry, click on plane command. And here, as always, we need to define two references. The first one, of course, is this line. And SolidWorks shows you the preview. For the second one, I'm going to select this top surface. And once I select it, SolidWorks shows you the preview of the plane. But this is not good for us, because right now the plane that is shown to you with the blue color is perpendicular to this pink surface. But what we need, according to the question, we need 75-degree angle. Now the question is, how can I define that angle? So the answer is clear with the relations. If you look at the second reference, which includes this pink surface, you can see that we have multiple options. And one option here is the angle. If I click on it, I can define the angle. If I change it to 75, now you can see the plane is defined with 75-degree angle with the pink surface. And that's the ideal plane that we want. Okay, so now click on OK, and that's it. Okay, so now we define the plane. Everything is ready to make a sketch on this plane and then extrude that sketch. So click on the sketch, and then select this plane 2. Okay, so here we need to make a 2D sketch. Click on line command. I click here, I go up, and then I can go to the right, going down, close it, and also I can click on circle command to make a circle like this. So this is one approach. You can simply use this approach and then add some dimension, whatever dimension you want to have. But this includes more steps. I want to show you an easier way to make this sort of geometry. Let's cancel this. Let's delete this feature, this one, this one, this one, and this one. Let's click on line command again. Start from this point, go up, click here. Now move your mouse to the outside, then go back here, and then go outside. And SolidWorks automatically changes the line command into arc command. And the nice part about this sort of command is that it automatically adds some sort of tangent relation here. Now I can go down and then go back. And you can see that this way it's much easier to design a part, right? So I simply used line command and then move my cursor outside, move it back to the line. So SolidWorks kind of got the fact that, okay, I want to change it to a curve or arc command, and then after that made an arc for me. And the nice part is that I don't need to add relations. It's tangent to this point, it's tangent to this point, and it's way easier. I just wanted to show you this approach. At the end of the day, it's your job to make a decision which way you want to go, whatever works for you guys. But I just want to show you two different approaches. Now it's time to add dimensions. According to view AA, I can click on Smart Dimension, and this radius is going to be 55 divided by 2. Also, the height of this feature should be 32 millimeter. And now you can see that the geometry is fully defined. I click on Circle command and make a circle here as well. Click on the Smart Dimension and add 25 millimeter dimension to it. Okay, so now we have a fully defined geometry. It's time to extrude this geometry. Click on Feature, click on Extrude Bus, and then here, first of all, we don't need it to be mid-plane, so click on it to change it to blind. And according to the front view, the thickness we need is going to be 10 millimeters, so this is 10. And of course, it should be in the other direction, so let's click here on reverse direction. And now you can see the preview. Click on OK, and that's it. That's the final geometry. Now it's time to check the total volume and make sure that this is a correct model. Let's go back to the question and check the total volume. In the question, you can see that the total volume is 132,174 cubic millimeters. Let's go back to our model and check the total volume. In SolidWorks, in order to check the total volume, you can click on Evaluate and then Mass Properties. And here you can see the total volume. The total volume is 132,173.5 cubic millimeters. If you round up this number, you're going to get exactly the same answer as shown in the question, which shows our model is correct and there's no problem with it. Okay, awesome. I think that's a wrap for this video. I hope you guys enjoyed this video. If you have any comments or feedback, please leave comments down below. Thanks again for watching. My name is Ruzbe. Hope to see you again soon in the next videos.